All right, so we're going to move on to the next topic, which is rational expressions. And when you hear the word rational in a math class, the first image that you should conjure up in your mind is of a fraction. A rational number is any number that can be written as a fraction. So anytime you hear the word rational, rational exponent, rational expression, rational equation, it's always having to do with a fraction. For example, these guys. These guys are these are two separate rational expressions, right? And so the first thing we want to take a look at is, one, how to evaluate them, and that's pretty simple. We're still going to plug in these numbers in for x and work them out. Quickly, if I plug in 1 for x, 1 squared is 1, 1 minus 9 is negative 8, then we get 1, 1 plus 1 is 2, 2 minus 6 is negative 4, that gets us 2. Plug in 3. 3 squared is 9, then 9 here, 3 here. 9 minus 9 is 0. 9 plus 3 is 12, minus 6 is 6. 0 divided by 6 is 0. Now plug in 5. 5 squared is 25. This is 25, 5. So we get 16 over 25 plus 5 is 30. 30 minus 6 is 24. That can reduce down to 2/3. Now, I'm going to also include 2 in here. I'm going to plug in 2 and see what we get. 2 squared is 4. 4 minus 9 is negative 5. 2 squared is 4 plus 2. 2 plus 2 is 6. 6 minus 6 is 0. And we cannot divide by 0. This is undefined. So we can't substitute any value in for x that's going to give us something mathematically impossible. And dividing by 0 is mathematically impossible. That means that right here, x cannot be 2. We can plug in anything else we want for x except for 2. Same thing on the other side. If we're going to plug in 1 for x, 1 minus 3 is negative 2. 1 minus 2 is negative 1, and this is 2. Plug in 3 for x. 3 minus 3 is 0. 3 minus 2 is 1. We just get 0. Plug in 5. 5 minus 3 is 2. 5 minus 2 is 5 minus 2 is 3. So you get 2/3. And if we plug in 2 here, we're going to get 2 minus 3 is negative 1. 2 minus 2 is 0. This again is undefined. So if you look, our results are the exact same when we plug in those same numbers, 1, 3, 5, and 2. So on the right-hand side expression, 2x cannot be 2 either. That means that these two expressions are exactly the same. These are two fractions that are equivalent. I shouldn't say the same. They are equivalent. It's a lot like taking 3 over 6 and 1/2. Those two fractions are equivalent. 3/6 and 1/2 are equivalent fractions, right? They mean the same thing. They're both a half, right? 0.5, 50%, however you want to look at it, right? Real quick, how do you reduce 3/6 to get 1/2? Way back when, you would have factored the 3 down into 1 times 3, and the 6 down into 1 times 2 times 3, and divided out those common factors, right? That's not what you do now, because you just divide the 3 and the 6 by the greatest common factor that they have. And I know that's a lot quicker than what you do now. Or this right here is a lot longer than what you do now. But that's basically what you're doing. You're dividing out a common factor. Well, check this out. If I factor x squared minus 9 into x plus 3, x minus 3, and x squared plus x minus 6 into x plus 3, x minus 2, these guys have common factors too. Remember, the factors are two things that get multiplied together to give you something different, something new, right? Well, these guys are being multiplied together, and these guys are being multiplied together. So these are all factors. I can divide out these common factors. The x plus 3 and the x plus 3 are common factors, and I'm left with, lo and behold, this expression over here, x minus 3 over x minus 2. Okay, so I can, same as the 3/6 to the 1/2, I can create equivalent fractions with my rational expressions by simply factoring and dividing out common factors. Unfortunately, there's not a shortcut than there is with the 3/6, just dividing the numerator and denominator by 3 and getting 1/2. We don't know what these common factors are going to be for our rational expressions until we actually factor them down. So that's what we're going to do. Okay? So again, you can only divide out, not cancel. You can only divide out if there's a common factor in both the numerator and the denominator. So this guy down here, factor, I can divide out. Now, I caution you, okay, because you're going to want to do this. If you're looking at x minus 3 over x minus 5, the x and the 3 there are not being multiplied together. They're being subtracted. Same thing down here with the x and the 5. They're not being multiplied together. So that means that the x's in the numerator and the denominator are not factors. So you cannot divide those out. You can't do that. We're only dividing out factors, and factors are things that are multiplied together. Okay? So be careful not to do that. All right, let's get into it. Start factoring, and if you don't know how to factor, I've been telling you guys for a long time now that you have to know how to factor, and if you don't, this is going to be very, very difficult. So you better start getting some help. Get in right away and get some help. Okay, but we're going to factor this, x squared minus 4x minus 12. You need to be able to factor into x minus 6 and x plus 2 over x plus 2, x minus 2. And then divide out your common factors. There's an x plus 2 and an x plus 2. And we get x minus 6 over x minus 2, and we are done. Okay? Now, restrictions. We need to talk about restrictions. Okay? And we should have done that before I actually divided out common factors. Like I said, in the original two expressions, we know that we could not plug in 2 for x because 2 would have given you a 0 in the denominator, and we can't divide by 0. Same thing for any other expression. When I factor these expressions down, I want to set those factors in the denominator equal to 0 and find out what x values would make the denominator 0. Because we can't get a 0 in the denominator. It doesn't make any sense. So if I set x minus 2 equal to 0, I get x equals 2. If I set x plus 2 equal to 0, I get x equals negative 2. So that means restrictions on the x are 2 and negative 2. X cannot be 2 or negative 2. Okay? Those are what we call restrictions. We want to keep looking for some restrictions here. That's going to help us later on down the road. All right? Number 2 looks like this. And we're going to factor the numerator into x plus 3, x minus 2, over 2 minus x. Now, restrictions, really quick, I set this equal to 0 to find out what would make the denominator 0. Add x to both sides, and I found out that x cannot be 2 because that would make the denominator 0, and so that's a restriction. Next thing I look for are common factors. I don't see any. So I'm going to flip-flop. So here's what I'm going to do. I'm going to use a little bit of a trick here. I'm going to write this in standard form. It's not in standard form. Standard form says write the highest exponent first and then decreasing order after that. So to rewrite this in standard form, taking the signs with each term, you get negative x plus 2. I still don't have common factors, but I can factor out a negative 1 from the denominator. Well, you can always factor out a negative 1. Always, as a GCF. And that just changes the sign. So now I do have x minus 2's that I can divide out. And so we get x plus 3 over negative 1, but I would write that negative 1 in the numerator and get negative x plus 3. Okay? A little bit of a math trick there. All right. Another one I'll walk you through. We need to factor these guys down. And the 4 term, you've got to factor by grouping. GCF in the first two is x squared, and you get x plus 3. GCF in the second two is plus 2. and x plus 3. All over x cubed plus 27. The cube root of x cubed is x. The cube root of 27 is 3. That's your binomial. Your trinomial comes from the first guy squared, then multiply the two together, and then square your last guy. And you soap the signs, so same, opposite, always positive. Alright, continuing to factor here, x squared plus 2. Whatever's outside the parentheses times whatever's inside the parentheses are your factors of the numerator. And we've already got factors of the denominator. Now, we would want to set each of these factors equal to 0 to find our restrictions. And from the first, x plus 3 equals 0, we're going to find out that x cannot be negative 3. But if you hold your pencils just for a second, you're not going to be able to factor this trinomial. That's the nature of the cube factoring. So you're going to have to use quadratic formula, opposite b, plus or minus b squared minus 4ac all over 2a. But watch what happens. This is going to give you negative 25. This is 5i, but these are imaginary restrictions, and we're only concerned about real restrictions. So we don't need these restrictions here. As a tip, if you can remember, when you do the cube factoring, you're not going to get any restrictions from the trinomial. It will always give you imaginary restrictions, which we don't pay attention to. Okay? Then divide out your common factors. You get x squared plus 2 over x squared minus 3x plus 9. And we're done. Okay? Alright, you try this one. Factor everything down. Look for GCFs as well. Remember, GCFs are factors too. So give that a shot. And then you can start the video up and see if you're right. And did you get this? Factor out a 2x from the numerator and a 2x from the denominator as GCFs. Your restrictions, set x minus 1 equal to 0 and 2x equal to 0. That means x cannot be 1 or 0. Right? But you see the factoring there. 2x squared minus x minus 1 factors into 2x plus 1 and x minus 1. Everybody divides out except for 2x plus 1. Okay? All right. Now, multiplying these expressions. We've done this before. We were multiplying the monomials together. We just multiply straight across and simplify. We can still do that here, but I want to offer up a different way to look at this simplifying that will help us with our other rational expressions with binomials and trinomials and things like that. But multiply straight across and then simplify those columns. The x to the third divide out to 1. Y squared over y to the third. 2 minus 3 is negative 1. Drop that negative 1 into the denominator to make the exponent positive, and you get 10 over 3y. But just like you were probably taught at some point when you're reducing just your normal fractions, you can diagonally or vertically simplify as well. Here's what I mean. I can divide x squared into both of these. X squared divided by x squared is 1. X to the third divided by x squared, 3 minus 2, is 1. So you would get x to the first power here. Right? And then you have an x to the first here and an x here that will divide out to 1. And then your y's. Cross simplify here. There's 2 y's here that we're going to divide out, reducing this by 2 y's, so you get y to the first. And so you would multiply straight across now. 5 times 2 is 10. In the denominator, 3 times y is 3y, and this is the same that we got over here. So cross and vertically simplifying work as well. This is going to help us with our other rational expressions. It may not seem as easy with these monomial guys, so you can still multiply straight across and then simplify after. But if you can make the diagonally and the vertical simplification work for you, then that would be a little bit better. Okay? If we're going to do that, then all of your exponents would need to be positive. So in number 6, we've got this y to the negative third. we would want to drop that down into the denominator and go ahead and make it positive. Normally, I wait until I'm all done with everything before I move to make positive exponents. But for this cross simplification and this diagonal and vertical simplification, I want to make sure that all of my exponents are positive. So I see that I've got 3 x's here, so I'm going to reduce this guy by 3. And then I've got 3 x's here, I'm going to reduce this x by 3 and get x to the first. The y's are both in the denominator, so I can't do anything with those guys. The numbers, the 3 and the 15, they're on the diagonal. They can be reduced as well. 3 divided by 3 is 1. This guy's going to be 5. 8 divided by 8 is 1. This guy's going to be 3. And then I multiply the 1 times the 5 times the x to the first. It's just 5x to the first over. The y squared times 3 times y to the fifth is just 3y, y to the third, y to the fifth. 2 plus 3 is 5. And then we're done. Okay? That works here as well. Multiplying these two fractions, I can diagonally or vertically simplify as well. I need to rewrite this guy in standard form. I'm going to factor the denominator into x plus 3, x minus 1. Then we go x plus 3, x minus 2. I'm going to factor out a GCF in the numerator of the first fraction, which is negative 4x, and get x minus 1. Run out of room here. So I've got an x plus 3 and an x plus 3, an x minus 1 and an x minus 1, and I've got a 4x and a 4x, leaving that negative. You have to remember, you have to pay attention to the fact that we're leaving a negative there, and then we have that x plus 2 that you can't really see over there. Looks like it should be a minus 2. Okay, and there you go. All right, number 8 looks like this. We can make the second guy a fraction by putting them over 1. And then it again becomes simply a matter of factoring and dividing out your like factors. 8x cubed and 1, this is a cube thing. So cube root these guys and you get 2x and 1. So we go 2x, 1, 4x squared, 2x and a 1. And then soap your signs. And then in the numerator over here, you're going to factor this into 2x minus 1. 2x minus 1. And now you're ready to factor out your common factors. There's a 2x minus 1 here and a 2x minus 1 here. And so we're left with x plus 3 times 2x minus 1 over 4x squared plus 2x plus 1. And there you go. Okay. All right. You try this one. Again, just factor everything out and divide out your common factors, both vertically and horizontally. And then check your answer. And did you get this? So 2x minus 8 factors into 2 times x minus 4. X squared minus 16 factors into x plus 4, x minus 4. X squared plus 5x plus 4 factors into x plus 4, x plus 1. X squared plus 8x plus 16 factors into x plus 4 and x plus 4. When the time you're done factoring out, now pay attention to this. Dividing out a common factor is a one-to-one thing. We use this x minus 4 to divide out that x minus 4. You don't get to divide out all of the x minus 4s that you see because they're all the same. It's a one-to-one. in order to divide out this x minus 4, we would have to have another one up here or here in the numerator. But we don't, so we don't divide it out. We've got to leave it in there. So what's left is 2 times x plus 1 in the numerator, and then x plus 4 times x plus 4 in the denominator. But since anything times itself, we can just square it. We can rewrite that as x plus 4 quantity squared. I'll take either one of these two answers. They are the same. Okay. Next, dividing. Okay. We want to divide now. Now, this is the same. Except you have to remember that when you divide by a fraction, it's the same as multiplying by the reciprocal. So you would need to change the division to a multiplication and then flip this fraction. Now notice that the y and the x have negative exponents in that second fraction. So in order to do this cross and vertical, diagonal and vertical simplification, I said before that all your exponents would need to be positive. So now I'm going to move just the x and the y to make those exponents positive. And then we see that we've got 2 x's here and 4 here, so we go 2. We've got 1y here, so this is going to reduce by 1. We can divide this by 5 and get 7 and 4. And by 9, we can get 3 and 4. And so what we're left with is 4 times x squared times 4 times x to the third, which is 16x to the fifth. And then we've got 7 times y squared times 3 times y to the fourth, which is 21y to the sixth. And we're done. So just flip that second fraction and multiply. This guy, factor this numerator into 3x and 2x, and then make this plus 3 minus 1 over 6x squared. Change to multiplication, flip this guy over, factor out a GCF, and you get 2x plus 3. And now we've got a 2x plus 3 here and a 2x plus 3 here. And so we get 3x minus 1 over 6x to the third. Go ahead and multiply these two together. And you get 3x minus 1 over 6x cubed. You can always back this up or even pause if this is going too fast. Okay, but your factoring should get to a point where it's pretty close to being this quick. All right? More examples. Again, flip the second fraction and just the second fraction, because that's what we're dividing by. Factor and divide out your common factors. This guy I'm going to rewrite in standard form. Times, flipping this over. All right, factor now. GCF of a negative 1 in that first numerator. GCF of that second one. And we get x minus 5 and x minus 2. X minus 5, x minus 5, x minus 2, x minus 2. And so we get negative 1 times x is negative x over 4x. Oh, look, we can divide those x's out and get negative 1/4. So all of this means negative 1/4. Wow, it's crazy. Okay, next one. Try this one, stop the video, start it back up, and check your answer to make sure you're doing it correctly. Did you get 5/3? Right? Again, flip the fraction and multiply the second fraction. And you can see how it factors there in the factors that we're dividing out. If that doesn't make sense, make sure you're coming in to get help. Okay? Pause the video if you need to see the solution and see if you can't figure out how we got to it, or just let the video play and we'll move on. Now, we've got 3 rational expressions here, but life doesn't get that much more complicated. We're still going to make this guy a fraction by putting him over 1. We're still going to flip this guy because we're dividing by that fraction. So times x plus 5 over 9x squared minus 25 is a difference of 2 squares. Square root 9x squared and you get 3x. Square root 25 and you get 5. And then we go plus or minus. And now we go looking for like factors. And it doesn't matter how far apart they are. As long as the factor is in the numerator of one fraction and in the denominator of another fraction, or the same fraction, we can divide them out. So these x plus 5s divide out. These 3x minus 5s divide out. And we're left with just x in the numerator and 3x plus 5 in the denominator. Okay? We can't divide those x's out because there's a 5 being added to the one in the denominator. So careful not to. Right? This one, not a lot different. Just we have to flip the second fraction. X squared plus x minus 30 will factor into x plus 6, x minus 5, times, flip it over and factor. So factor this, and you get x plus 3, x plus 4, over, factor this, and we get x minus 5, x plus 3, times x plus 6, and rewrite that numerator. So I would rewrite this as negative x plus 5, and then factor out a GCF of negative 1. Now we go looking for common factors. There's an x plus 3 and an x plus 3. There's an x minus 5 and an x minus 5. And that leaves us with x plus 6 times x plus 6 times x plus 4 and then we go x minus 5 times x minus 3. Wait. No. Sorry. The x minus 5 times negative 1. The x plus 3 is already gone. It's already divided out. And there we go. Okay? All right. So now we're flipping this guy. X squared plus, and then we're factoring. So I'm going to go ahead and factor at the same time. So we get x plus 7, x minus 1. We do not flip the second fraction because it's not behind the division sign, but the next one is, and now we go looking for common factors, and x plus 7, x plus 7, x minus 1, x minus 1. The 3 and the 6 reduced to 2. The x and the x squared. So this is going to become a 1. So in the numerator you got 2 times 4, which is 8. Denominator we've got just x, so it's 8 over x. Okay? Yeah, just like that. And last but not least, you got this guy. So again, don't forget to flip the second fraction, factor it down, and then try to divide out your common factors. Okay? Did you get 2 times x plus 2 over x plus 6? Okay, you can see how everything factors there, and you can see the factors that were divided out. If this doesn't make any sense to you, then you've got to get in here and get some help. Okay, Homework's out in Canvas. Knock it out by next time.